go over a review for what we've done so far in Chapter 1 and Chapter 2. So to start off, we have some expressions to evaluate. We want to make sure in these expressions that we use PEMDAS. So in number 1, for instance, we have addition and subtraction. We do addition and subtraction from left to right. So we would want to do the 3 plus 4, which gives us 7, and then drop down the minus 6. 7 minus 6 is 1. And so that would be our answer. On number 2, we've got multiplication and subtraction. So we have to think about which of those can come first. Subtraction is always last with addition. They're last. So we want to multiply and do 3 times 5, which is 15. Then we want to subtract 4, and that equals 11. Number 3 is tricky. It's designed to test you on your PEMDAS skills or your order of operation skills, because if all we have is multiplication and division, we do them from left to right. So we don't multiply and then divide. It all depends on the order. So if it helps, you might cover up the everything but the 5 times 6 and do that. And then do the next part. So cover up the 2. We want to do 30 divided by 3, which is 10. And then we want to times by 2 and get 20. It's really easy because it looks like that's what should happen. It looks like we should do 3 times 2 first and then divide. And it even works out nicely on this problem. But we want to do it from left to right. Only thing we're dividing by is 3. And if we do 3 times 2 and get 6 and then divide, we're dividing by too much. Now on 4, we have division twice and addition in between. So we need to do both of those different division problems and then add our answers. So 10 divided by 5 is 2. 8 divided by 2 is 4. We're going to put a plus sign in between, and 2 plus 4 is 6. And then 5 gets a bit more complicated. So we've got parentheses, which come first, but we have parentheses inside of parentheses. We always go to the most inside parentheses first. We want to take care of what's inside here. 6 minus 3 is 3. We have an exponent. We're going to square the 3 and then subtract 5. That's all for that parentheses. Once we know what that is, we'll do 16 divided by that. So 3 squared comes first. That's 9. Minus 5 is 4. 16 divided by 4 is 4. And then on 6, we want to take care of parentheses first. We want to do 4 times 2 and then add 1. We always add or subtract last in the order of things we do. So we're going to do 8 plus 1, and then we're going to divide by 3. So that's 9 divided by 3, which equals 3. Let's see, we're going to just move this up here and focus on our next section. So we've got a section from 7 to 10 where we have expressions and we need to put in numbers where our letters are and then evaluate the expression. So the very first thing we do on 7 is say, if x is 3, I'm going to put the 3 here, y is 1, so I'm going to put a 1 where the y is. So I'm going to figure out what 3 squared plus 1 is using order of operations. So that gives me 9 plus 1, which is 10. And then I'm going to do the same thing on the rest of these. So just make sure that you put the right number for the right letter, and then following order of operations is the other big thing. Now if I put 4 for both x and z, they happen to be the same thing. 4 minus 4 is 0, and then I add 2 to that, and I get 2. On 9, this one looks a little bit more complicated, so we got to make sure that we write it out correctly first. We've got 2 parentheses, 4 minus 6 divided by 6. Now, order of operations says look in the parentheses, and inside of our parentheses, we need to do the division here before we do our subtraction. So 6 divided by 6 is 1. I'm going to do 4 minus 1 as my next step. 4 minus 1 is 3. So 2 times 3 is 6. And that's my answer. And then finally, x and z are both 2. And this last one like this that we have, so 2 minus 5 minus 2 divided by 3. Well, parentheses first, 5 minus 2 is 3. And then I want to do 3 divided by 3, which is 1, and then do 2 minus 1. So it's really important to remember what your order of operations are so that you do things in the right order. Super duper important. Let me see if I can move this up again. Yay. Now we're looking at basically adding, subtracting, and multiplying, dividing positive and negative numbers. So on 11, when I do 2 minus 6, because I have a positive 2, and I can think of this like I've got a negative 6, that means that I need to think about how far apart these numbers are. 2 and 6 are 4 apart, and since the 6 is the bigger number, this would be negative 4. On 12, this may look weird, like you might at first think this is asking you to multiply, but we would have to have parentheses around the negative 5 or a dot, a multiplication dot somewhere for it to be multiplication. It's asking us to do negative 1 minus 5. Since they both are negative, that means they're making each other more negative. So this is where we add them together and keep the negative sign. So since this is subtraction, or you can think of this problem like negative 1 plus a negative 5. We could rewrite it that way if we wanted to. So that also gets you negative 6 when you're adding two negative numbers. 13, we want to take this negative 5 and change it to a positive. And we're allowed to do that because that's what that's saying. Like minusing a negative is the opposite. It's really like adding. So if there was an exponent somewhere, we'd have to hold off and evaluate the exponent first, but there's not. So negative 2 plus 5, how far apart are those numbers? They are 3 apart, and 5 is the bigger number and it's positive, so our answer is positive 3. On 14, we have some fractions. So if I want to add fractions together, I need a common denominator. For 2 and 3, my common denominator would be 6 because I can multiply 2 by 3 to get 6, which I'll do to the top and the bottom. And I can multiply the 3 by a 2 to get 6. And so that means that I have 3, 6 plus a negative 10, 6. And then we have to think about how far apart is 3, 6 from negative 10, 6. They are 7 apart. And the bigger number here, the bigger numerator is negative. So this is negative 7, 6. Then we've got some products. So remember that having one negative when we multiply makes the whole thing negative. Having two negatives, they cancel out and make it positive. Or we could have 3 negatives even, and that would 2 of them would cancel and we'd have a negative left over. So before I even actually work out what the numbers for these are, I can figure out if they're positive or negative. Negative 2 times negative 4 will be positive 8. Negative 9 times positive 9 has a single negative, so that makes it negative 81. Negative 2 times 6 times negative 2, since there's 2 negatives, will be a positive number. And then I just have to multiply that out. 2 times 6 is 12, times 2 is 24. And that's the front side of the review. Now we're dividing. So the same rules for multiplication apply to division, where if there's a single negative, it makes it negative. If there are two negatives, it makes it positive. And we usually don't divide three numbers, so we don't really have to worry about that. So on 18, we have negative 20 divided by 2, which gives us negative 10. On 19, we have negative 12 divided by negative 3. They're both negative, so that turns it into a positive, and that would be 4. Now, on a problem like 20, where we're adding fractions in to make this a little more complicated, I would personally look at this and say, one's positive, one's negative. I know that means this ends up being negative. And then don't worry about writing the negative down the whole way through to work it out. Because when we divide fractions, we have to say, what is it when we flip the second one? So we have to find the reciprocal of the second one and say, okay, what is 7/4 times 8/7? Now, if we remember that whole canceling thing, that will make this easier. I can cancel the 7s, I can cancel the 4 and the 8, and that leaves me with a 2 on top. Everything else canceled, so the answer to this is 2, but don't forget it's really a negative 2. That section. So now let's make this more complicated a little bit. And basically we want to use PEMDAS now, but we also, in this first one, 21, we've got absolute values, absolute value bars. So they're like parentheses, but they're straight up and down. They're not quite square brackets, so there's a difference there. What we want to do is figure out the inside of our absolute value bars first, which -1, -1, -2. But when I do the absolute value of -2, that changes it from negative to positive. So that would really be a positive 2. Then I'll write down the rest that I haven't done yet. So -4 divided by 2 minus 6. Division comes before subtraction. -4 divided by 2 is a -2. I'm going to subtract 6. Those are making each other more negative, so that I get -8. On 22, we want to square the 6 first. And so since the negative's inside of the parentheses with the squared, we're going to make that be positive 36. Okay, and this is a tricky thing. If this was -6 squared without any parentheses, we would say 6 squared is 36, and then we would put the negative in front of it. But that's not what's happening here. Since the negative's inside parentheses, it switches to positive 36. So we're doing -1 plus 1 plus 36, which means that this is 0 plus 36, which is just 36. Next, our section is all about adding like terms and the distributive property. Good old distributive property. What would we do without it? So when we don't have parentheses and we're trying to simplify an expression that has letters in it, we're looking for things that are considered like terms. Numbers can be like terms, so the fact that we have a -2 and a positive 6 that don't have another letter with them, we can add those together. -2 plus 6 is 4, because they're 4 apart, and 6 is the bigger number. And then we can also put V's together. In this case, that's our letter that we chose to use in this problem. So if I have -2V and I add another V, what happens is that makes it be -1V. You can write -1V, or you can just write V. So either of these are fine. Those are both the correct way of putting that. But it doesn't turn into V squared, because that only happens when we multiply. When we're adding things together, if I have 2 V's and I do something to those 2 V's, I still have to have V's when it's adding or subtracting. It doesn't change into V squared. So the same kind of thing is going to happen on 24. The 6 this time doesn't have anything to add with, so it's going to stay a 6, but the 4x and 10x can add together, and that will give us 14x. So that our answer here would be 6 plus 14x. when we do have parentheses mixed in with variables, we're going to use the distributive property because we can't add we can't add n and 8 together, which means the only thing we can do to make this any simpler is distribute. So to distribute, we multiply because there's nothing right here in between the 6 and the parentheses, which means multiplication. So 6 times n is 6n, and 6 times 8 is 48. So our answer to this is 6n plus 48. Oh, and this problem has a similar set of numbers and a similar letter. We're going to distribute 6n. So we do 6n times 8. If it helps you too, you might think about writing this out. 6n times 8 is the first thing we're going to do. And then we're going to do 6n times negative 10n. And in between those, I'll put a plus sign for now, because I'm not sure if it should be a plus sign or a minus sign. 6n times 8, you multiply the numbers together, and you get 48n, because this had an n and this doesn't. It gets n. But this other one, 6 times negative 10 is negative 60. So I'll put minus 60. N times n is n squared. If you think about it, that's the whole definition of what n squared is. It's n times n. Just like 2 squared is 2 times 2. So that is our answer because n and n squared are not like terms. You cannot put n and n squared together. N squared can go with other n squareds, but it can't go with n's. Almost done here. So we're going to distribute and get 10 times b, which is 10b. Then we'll do 10 times negative 2 and get negative 20. And this minus b at the end, it's not being multiplied. There's not a dot, there's not parentheses, so that is saying minus b on the end. So right now it's just going to stay minus b, and then we'll check for like terms. Anytime after we distribute, if there's something else around, there's probably like terms that we can add. In this case, it's 10b and negative b. 10b minus 1b is 9b. So this is 9b minus 20. And the next ones are going to go similarly to what we've already done. So negative 2x times x. Since they both have x's, that's x squared. Negative 2x times 5 is negative 10x. Plus 5 squared is at the end. We have like terms at the beginning and end here. Negative 2x squared plus 5x squared is 3x squared. Positive 3x squared minus 10x. And that's our answer. 2 more. Now, even though the negative 1 is at the end of the parentheses, what matters here is that between these two things, there's not an operation. We just have these parentheses meeting, and that means this is multiplication. So we're going to distribute a negative 1 into this parentheses. That means this 5 in front is still going to be in front. We're going to do negative 5a times negative 1, which is a positive 5a. And then we'll do negative 5 times negative 1, which is positive 5. We'll add our like terms. There's lots of 5s in this problem. Our like terms make this 10 plus 5a. And that's our answer. You also, on each of these, could have written them in the opposite order. Like you could write 5a plus 10, and that would be the same answer. Here, I'm going to distribute negative 2r. Negative 2r times 1 is negative 2r. Negative 2r times r is negative 2r squared. Remember, r times r gives us r squared. But when we do r with just a number, it keeps its r. Like a pirate. R. Here, we want to add our like terms, which are the r squareds. Negative 2, and then negative 2r squared minus 4r squared is negative 6r squared. Hey, by the way, what is a pirate's favorite math formula? It's pi r squared. Have fun reviewing for your test.